Hello and welcome to this Price of Job tutorial. In this video we will explain how to use the timber beam calculator to BS5268 through an example. Initially we'll go to the top navigation blue toolbar and open the Engineering tab. Then browse through the Module toolbar where we can select from a variety of different engineering modules. And here we can open the timber beam category and select timber beams to BS5268. The module appears in the left sidebar where we can rename the category from structure to something more project relevant by clicking the pencil here. So rather than structure, let's call this extension. And then we can rename the specific calculation that we're going to do by clicking the three dots to the right to open the module options and then select rename. And here we might title this one something like ground floor timber beam number 1 and save. And now we can select this module. And this opens the description in the center pane, and the module stages in the right sidebar. To get started, we'll take a look at the timber design. Initially, we enter the effective span. This should be in millimeters. The effective span is the clear span of the opening plus the bearing on one side plus the bearing on the other side. In this case, the clear span is 1,800 millimeters, and the bearing on one side is 100 millimeters, and the bearing on the other side is 100 millimeters. So in this example, we will use an effective span of 2,000 millimeters. We can input that by adjusting the slider to select the measurement that we wish, or it might be easier just to simply input the exact number that we know we want our span to be. In this case, 2,000 millimeters. And just above our measurement, we have here our single span, and if we click on the checkbox on the left, we can add a cantilever on that side. If we click the selection on the right-hand side, we can add a cantilever on that side. However, for this example, we will not use any cantilevers. Utilization limit is recommended to be set at 99%. We have a special video for the utilization limit explanation in our video section. We recommend using a bearing length of at least 100 millimeters. Sometimes longer bearing is required to satisfy the bearing stress check, which we can see here in the description. The bearing stress status is currently a pass, so in this case 100 millimeters will do. The beam rotation is the angle between the horizontal and the timber beam. In this case we will use 0 degrees because in our example the timber beam will be horizontal. Then we can click the Options button and input our safety factors. It is recommended to set safety factors to unity, both for permanent dead and for variable live loads. Under the first Options menu, we see there are 3 different service classes to choose from. Class number 1 is when we have a heated and dry environment. Class number 2 is when we have a cold and dry environment. And class number 3 is when the timber is exposed to weather. For example, a timber beam that is half covered by a roof and half uncovered and exposed to the weather conditions such as rain. So for our example, we'll use class number 2, cold and dry. Under the load duration drop-down, we see 4 different types of load duration: long-term, medium-term, short-term, and very short-term. For long-term, this is usually dead loading, such as self-weight or storage combined with permanent imposed loading. In this case, we use 1.0. For medium term, this is usually snow or temporary imposed loading combined with dead loading. In this case, we use 1.25. For short term, this is usually wind or snow with wind combined with dead and imposed loading. In this case, we use 1.50. For very short term, this is usually wind combined with dead and imposed loading. In this case, we use 1.75. For our example, we'll select long-term, 1.0. Now under the depth to breadth ratio, we will need to identify the restraint conditions of the end supports and the compressive edge of the timber beam. This is difficult to be done for timbers. As a result, conservatively, you can choose either no lateral support or ends held in position. For this example, we'll use number 7, ends of the beam held in position and both ends held in line. After that, we have 3 checkboxes. If the timber beam is acting as a trimmer post or lintel, then you can click this box. If we scroll down the description to the modification factors, we can see that clicking this box will change the load sharing factor from 1 to 1.1. This will increase the strength of the timber beam. If the timber beam is part of a load sharing system such as roof joists or floor joists, then you can click this box. This will change the load sharing factor from 1 to 1.1. This will increase the strength of the timber beam. If the timber beam has a wane at the bearing, then you should click the third box. This will reduce the strength of the timber beam, and we can see the calculations represented in the compression perpendicular to the grain calculations. Then we'll move on to deflection limit. Maximum deflection is recommended to be set at 0.003 multiplied by the effective span, or a preset value of 14 mm for dead and live loadings combined. The calculator uses the minimum of these two values. So for these options, we'll keep the default selections of dead plus live loadings and span multiplied by 0.003. You might also choose span multiplied by 0.002, and this is used when the timber beam is above a bristle element, such as a bifolding door. Such a deflection limit will usually demand a deeper timber beam section than the 0.003 multiplied by effective span deflection limit. For this example, we would use span multiplied by 0.003, or 14 mm for dead and live. And then we can close this window. And now we can move on to the loading input. What is the timber beam going to support? If we want the self-weight of the timber beam to be included in the calculations, then we check this box. And if we scroll up in our description, we can see the changes represented in the results summary and diagrams. And if there is tension applied to the timber beam, then we can include tension by clicking this box, and then inputting the tension value. In this case, we'll use 1 kN applied tension, and this adds the tension stress calculations to our description. Now, this is the diagram of our example, and this is the timber beam. And we can see here that we have a trimmer beam, which is supported off the timber beam. And also, our timber beam supports floor joists on either side. In this example, we have a timber trimmer joist with a dead loading of 1 kN and a live loading of 1.2 kN. This is a concentrated loading. The trimmer joist is applied in the middle of the timber beam. So let's input this into our calculator. First, we'll click the plus button to add new load. And then we can change the load title to Timber Trimmer. And then select the load type menu and choose concentrated point loading. And then input the dead and live loadings from our example. In this case, 1 kN and 1.2 kN. And this is applied in the middle, so that would be 1000 mm. Now if we refer back to our diagram, we see that we also have timber floor joists from both sides supported off the timber beam. On one side, the timber floor joist span is 2000 mm, and the other side of the timber floor joist span also 2000 mm. Therefore, half of the loading on one side and half of the loading on the other side is supported on our timber beam that we want to design. So 2000 mm divided by 2 on one side plus 2000 mm divided by 2 on the other side gives us a width of loading perpendicular to the beam of 2000 mm. So let's go back to the loading inputs and click plus add new load. And rather than input the values manually, we can click on the pencil icon here to open the Price of Job Templates library. And from the drop-down menu, we can select Timber Floor. And the calculator is automatically loaded with the template values, including 0.46 for dead and 1.5 kN per square meter for live. Then we see underneath the width of load perpendicular to beam. This is also called the influence zone, and this is what we calculated to be 2000 mm. And when we close this window, we see the Price of Job has automatically calculated the loading from the timber floor joists. And we can just customize this template title for clarity and retitle this one Timber Floor Joists. Now if we click here in this checkbox, we can show the load details in the report by scrolling down. If we deselect this, then the loading details are not indicated in the report. We'll leave this selected to show the load details. Next, under Section, the Auto Search feature will help us to optimize the timber beam quantity, width, and depth. If we unclick Auto Search, then we can choose the quantity, width, and depth that we want. Using this selection, we can choose the quantity of timber beams, either 1, 2, 3, 4, or 5. In this example, we will use a single timber beam. And then we can use the drop-down menu to select a width of 75 mm and a depth of 225 mm. If we increase the number of beams, we can see the section becomes less wide and less deep. If we decrease the number of beams, then we need a wider and deeper section to satisfy the structural checks. Based on the rest of the input in the previous sections, if we click Auto Search only for the depth, then the calculator will optimize the depth for a given width. Based on the input of the previous sections, if we click Auto Search only for width, then the calculator optimizes the width for a given depth. And here we enter the timber strength, or timber grade as we call it. Usually we choose C16 or C24 for softwood. The modulus of elasticity affects the structural calculations. It mainly affects the deflection calculations. But changing the modulus of elasticity from the minimum value to the mean value can have a drastic effect to the design. The mean modulus of elasticity should be used to calculate deflections and displacements under both dead and imposed load, unless the imposed load is for an area intended for mechanical plant and equipment, or for storage, or for floors subject to vibrations, such as a gymnasium or ballroom, in which case the minimum modulus of elasticity should be used. Also, the deflections of solid timber members acting alone should be calculated using the minimum modulus of elasticity for the strength class or species and grade. For this example, we'll use the mean value. With this checkbox, you can include notches of the timber beam at the support locations. By selecting the Notches menu, you can choose a type of notch to be used, either top or bottom. Set the dimensions, and select Support A and Support B. However, in this example, we will not be using any notches, so we'll deselect this. Now let's take a look at our results. At the top of our description pane, we can see a summary of the results. In the following sections, we can see the design data, the loading details, the supports, the beam details, the modification factors, and the rest of the calculations in detail. Regarding the results summary, you can see that all checks have a status of pass. Also, we can see the utilization factors. Now that this timber beam is done, if you have to do the same calculations for another timber beam, instead of starting all over again, from scratch by starting a new module, you can save a lot of time by simply clicking the 3 dots next to the module here to open the Module Options menu, and then select Duplicate Module. And this creates an exact copy of our existing module, and then we can select the 3 dots to open the Module Options menu, and then rename this new module. Perhaps we'd call this Ground Floor Timber Beam Number 2. And save. And now we can just modify the values for the new timber beam. When you are ready, you can click on the Reports tab here in the left-hand sidebar. And here you will see the Structural Calculations page. If you click Export as PDF, you'll see that your logo will appear automatically to be shown at the top of the preview, and you can customize this as necessary. At the bottom, there is a section for adding notes, which you can either input manually or select the plus icon to add professionally written notes from the Price-A-Job library. For example, we might select the category Structural Members, and then click this note to have it instantly added to our page. We can also add new notes to this template library by clicking plus Add New Note, and then type our new notes here, and save. Or we can add new categories of notes by clicking the plus Add New Category button here at the bottom. Here under the Substructure category is another good example. We can see that this is particularly handy for adding legal disclaimers. Once we've added our notes from the template library, we can close this window and then edit our notes as necessary by simply changing them within the field. So for example, we might change this from steel beams to timber beams. You can also combine this structural calculation page with a cover page and cover letter. The cover page is customizable by clicking the pencil icon, and you can customize this to either show the quote, or a detailed address, or simple. And for the cover letter, you can write whatever you want in this field, and then save it as a template by clicking the 3 dots here next to the Templates menu. Give your new template a name, and save. And all of your saved templates will be available to you under this drop-down menu for future use. When you're done, you can print the complete report, or export it as a PDF, or as a Word document, or you can email it directly to your client or contractors directly from within Price-A-Job. And that's how to use the Timber Beam Calculator to BS5268. Thank you for using Price-A-Job.